getting some less than 7. So that means a 2 works, so I got 1 over 36. 3 works, that's 2 over 36. 3 works, so that's, 4 works, so that's going to be, let's see, I got them 1 out of 32, got lost. 3 out of 36. That was for 4. For 5, it's 4 over 36. And my last one's going to be the 6, because it says less than 7. So you got 1 plus 2 is 3, plus another 3 is 6, plus 4 is, plus 4 is 10, plus 5. That's 15 over 36. And that's going to be 5 over 12. Okay, what's the probability of a sum less than 12? I'm going to show you a trick on this one. If it's less than 12, that's basically all of these numbers right here, 2 through 11. So what I would do is add all of those. But if you'll remember, those all add up to 1, right? So since this is the only one missing, I'm going to take the 1 and I'm going to subtract that 1 over 36, and that's 35 over 36. Now, if I wanted to, I could change that to a decimal, but we're going to keep our numbers simple. Okay, what's next? Okay, so let's say we have this example here. It says, let E and F be two mutually exclusive events, and suppose the probability of E is 0.1, probability of F is 0.6. Find each of the following. Now, before I go on, we did this last chapter. Let's go back and do ourselves a Venn diagram. How did I know it looked like that? Mutually exclusive says that the circles don't intersect. So when you do this, I'm going to go back to my other pen and make it a little darker. What you do here, the probability of E was 0.1, so I'm going to put 0.1 right there. And the probability of F is 0.6. There was just no overlap. So now go back and answer the questions. The probability of E intersect F. Well, they do not intersect, so that's going to be 0. And that's always going to be true on mutually exclusive. If it's E or F, all you're going to do is add those. So 0.1 plus 0.6, and that's going to be 0.7. Okay, what about the complement of E? Well, if E is 0.1, then the complement of E is everything else. So that'd be all of this out in here. So that's going to be, let's think of it this way, 1 minus, if everything's 1, I'm going to subtract 0.1, and I'm going to get 0.9. Okay, what about the probability of not in E and not in F? Well, that's all the stuff outside the two circles. Well, inside's 0.7, right? So if I take 1 minus 0.7, that means everything out in here is 0.3, and that's my answer right there. Okay, and the last one's a little tricky. This one says it's not in E or it's not in F. So if it's not in E, that's all of those. If it's not in F, that's all of those. Since it's or, that's the union, the answer is going to be 1. There's nothing that is not in the set because everything's taken care of. That one's a little bit harder to see. Probably won't have a question quite like that. Okay. Let's see. Okay, let's go to this one. Let E and F be two events of an experiment with sample space S. We know the probability of E is 0.2, the probability of S is 0.1, and the probability of the intersection is 0.05. So let's draw our diagram. Now on this one, there is an intersection. It does not say mutually exclusive. Matter of fact, it says E intersect F is 0.05. So I'm going to put 0.05. It's probably not going to show up. This is probably going to make it too bold. 0.5. I guess that's not too bad. Okay, this is E, and that's F. So to find out this number here, the whole thing for E was 0.2. So if I take 0.2 and I subtract 0.05, that's going to be 0.15. That's this number right here. This number, the whole thing in F was 0.1. So if I take 0.1, subtract 0.05, that's going to be 0.05. Okay, so if I want to find E union F, I could just add those together, or I could use that property, that inclusion-exclusion property. I'm going to take the 0.1 plus, now let's make it 0.2 plus 0.1, and I'm going to subtract 0.05. And when you do that, that answer is going to be 0.25. You get the same thing if you add 0.15, 0.05, and 0.05. Okay, the next one says the complement of E or the complement of F. So if it's outside of E, it's all of those. If it's outside of F, it's all of those. What's missing? That right there. So it's going to be 1 minus 0.05. And that's going to be 0.95. Okay, this says the probability it's not E or it's in F. Not E is everything outside the circle, or F is all of these. The only thing we're missing is the 0.15. So if I start and I take 1 minus 0.15, that's equal to 0.85. Let's do it a different way. If I take all of these and add them together, I already got it was 0.25. So if I take 1 minus 0.25, that means this out in here is 0.75. Okay, I could do the same problem down here if I just add them together. Let's start with a 0.75. I'm going to add 0.05. And I'm going to add another 0.05. And that gives you 0.85. The one that's left out is this one, because that doesn't hit in either one of those. It does not fall in the complement of E, and it does not fall in F. Therefore, that's excluded. That's why I subtracted. Subtraction is just a little bit easier. Okay. Example 8, a card is drawn from a well-shuffled deck of 52 playing cards. What's the probability it is an ace or spade? The probability of an ace or spade. Okay, first of all, what is the probability of getting an ace? How many aces are in a deck? 4. There's 4 aces out of 52. In lowest terms, that's 1 over 13. I'll probably leave it as 52. You'll see in a second. What's the probability of getting a spade? Now, when you have a deck of cards, there's 4 suits. I hope most of you guys know this already. There's hearts, clubs, spades, and diamonds. There's 13 spades out of 52. There's actually 13 of each suit. Now, if I put that in lowest terms, that's 1/4. Here's what you got to realize. What's the probability of getting just one card that's an ace and a spade? In other words, the ace of spades. There's 1 out of 52. That formula I had earlier, if I want the probability of an ace or a spade, I can get that if I take the probability of an ace plus the probability of a spade minus the probability, I'm just going to write the word both. That means an ace and a spade. So we know the probability of an ace is 4/52. Got that over here. The probability of a spade is 13/52. Minus the probability of both is 1/52. You'll notice I kept them over 52 because when you add or subtract fractions, you got to have a common denominator. So 4 plus 13 is 17. 17 minus 1 is 16. 16/52. In lowest terms, that's 4/13. Okay, so they're starting to get a little tougher, aren't they? Okay, here's the last thing, and I think this is actually a simple concept. Another way of thinking of probability is odds. It's really a different way of saying the same thing. It's still a measure of how likely an event will occur. We don't use odds. A lot of times you'll see it in the paper, and many people use it the wrong way. One place you do see it a lot is horse racing. So let's say I'm flipping a coin. We know the probability of heads is 1/2. That's 1 out of 2. And I like to think as probability as good over total. That's what I did here. Heads was 1 out of the 2 total. 1 good out of 2 total. Odds is good, and what they usually do is they put a colon in there, good to bad. So as far as flipping a coin, if heads is good, and one coin there's 1 good, and there's 1 bad. So odds would be 1-to-1. If I was tossing a single die, the probability of getting a 5 is 1/6. The odds would be 1-to-5. 1 good, 5 bad. Okay? Again, if I'm tossing a single die, if I want the probability of getting greater than 4, if it's greater than 4, it's either a 5 or a 6. So that's 2/6 or 1/3. The odds would be 1-to-2. These two always add up to the bottom number. First number is always the same. So if the probability of rain is 2/5, that's a fraction, 2/5, then the odds would be 2, work backwards, 5 minus 2 gives you 3. Remember, these two always have to add up to the bottom number. And if we went backwards, if the odds are 5-to-2, then the probability would be 5 over what? 5 plus 2 is 7. Okay, that takes care of section 6.2. Did it all in one lecture. I believe we have 2 more after this. We'll be done with chapter 6, and we'll be done with everything we need to do. All right, see you next time.